Hello everyone. So this video is in continuation to the previous video where we discussed about atomic numbers chart 1 to 10. I'm going to continue from there only. So we discussed about electronic configuration, valence electrons, valency, mass number. I even told you about isotones. So how to remember the mass numbers from the atomic numbers, so that trick we discussed. So now we are going to continue with the next 10 atomic numbers. So we are going to start with 11, that is sodium. So it's a metal. Symbol for sodium comes from the Latin term, that is natrium. So most of the element symbol come from Latin or it's Greek. So why do we take symbols from these languages? Because these are somewhat, we call it as dead languages. Nobody practice them much, but they hold a very important significance when it comes to chemistry. So in order to be universal symbols, so we always try to take from these languages. So we are going to write K, L, M, N shells again. So we have out of 11, we'll have 2 electrons in the K shell, that we know K shell capacity is for holding 2 electrons. Then we have 8 electrons, that is the maximum capacity for L. So this is completely filled. K and L are filled. Now 8 plus 2 is 10. Left over 1 electron from 11 will go to the M shell. So valence electrons that we have are valence electron that we have is only one. This is our valence, the outermost. So innermost is the one which is in connect with the nucleus, the very first shell, that is K. Outermost depend upon the number of electrons. So we have valency, it's going to be 1 because it has only one electron in the outermost shell. Mass number, that is 23. Double of atomic number, that is 24 plus 1. Double plus 1, so number of neutrons that we have over here is 23 minus 11, 12. Then we go to the next element, that is magnesium. Mg is a symbol. It's a metal. So 2, 8, 2 electrons. So now M shell will keep on filling. 2 valence electrons. Since we have 2 outermost shell electrons, valency is going to be 2 because it has 2 electrons in the outermost shell. Mass number is double of atomic number, 24. Again we have 12 neutrons. So we are going to write the example in the back again in the isotopes part, which is your another example, sodium 11, atomic number 23 is the mass number, and we have magnesium 12 and 24. So we have 12 neutrons. So these are another example of pair of isotones. Then we go to 13th, that is aluminium. Al is a symbol, it's a metal. So 2, 8, 3. 8 plus 2 is 10, 10 plus 3 is 13. 13 is our atomic number. 3 valence electron, valency is 3. Mass is double of atomic number plus 1, that is 27. 13 plus 13 is 26. Plus 1, 27. 27 minus 13 will give us 14 neutrons. Then we go to 14, which is our silicon. Si is a symbol. It's a metalloid. Metalloid, or we call it as a semi-metal. Semi-metals have properties intermediate of metals and non-metals. So we have 2, 8, 4 configuration. Valence electron is 4. Valency 8 minus 4. same 4. So mass is double of atomic number, that is 28. 28 minus 14, that is again 14 neutrons. So we can write another example of isotones over here. So this is going to be aluminium 27, silicon 28, that is 14 neutrons. Just remember one thing, that if you have different mass number, if you're taking any other isotope of silicon, aluminium, or any other element, so the number of neutrons will vary. So we need to, that's why I'm very much highlighting over here the mass number. We don't have any role with the atomic number, that's a fixed number. The atomic number is a proton number, it's a fixed number. But mass number definitely can vary. Then we go to the 15th. So we leave a little bit space over here for adding more example. 15 is phosphorus. P is a symbol. It's a non-metal. So we have 2, 8 and 5 configuration. Valence electrons are 5. Valency is also 5. Mass number that we have over here is 31. So 31 minus 15 is going to be 16 neutrons. Then we go to 16, which is sulfur. S is a symbol. It's a non-metal. 2, 8 and 6. 6 valence electron. Valency is going to be, okay, my mistake. Please change over here. Valency is 8 minus 5. That is 3. So 8 minus 6, that is 2. So mass is going to be 32, double of atomic number. 32 minus 16 is 16 neutrons. So we can add this example again. Phosphorus 31 and sulfur 32 have both 16 neutrons. Then we go to 17th. That is chlorine. It's a non-metal. 2, 8 and 7. 7 are the valence electron. Valency is 8 minus 7, 1 again. Mass, I'm going to write 2, 35 and 37. So again we are going to introduce one more concept over here, that is your concept of isotopes. So iso means same, as I've told before. So these are atoms having same atomic number but different mass number. So I'm going to write example of chlorine, atomic number 17, 35 is a mass number, 37 is a mass number, and we can take some more examples. I want to talk about this isotopes part in a separate video, but yes, there's no harm in taking multiple examples because they definitely ask in multiple choice questions, MCQs, and even in the subjectives. So it's always better to have a lot of knowledge about the examples of isotopes. So we have hydrogen, 3 isotopes are there. So we call this as protium. Protium is our normal hydrogen. We even represent with the symbol P. And then we have deuterium. Deuterium, dew stand for 2. So we represent with the D symbol, deuterium D2O. That's a chemical formula that is used as a heavy water. Why do we call it as heavy water? Because of the higher mass of deuterium over there, which is one of the isotope of hydrogen. Then we go to the third one. This is tritium. Some people pronounce it as tritium, tritium, whatever you want to pronounce, your wish. So over here we have 3 mass number. And do remember, isotope, they have different mass number, same atomic number, but They differ by number of neutrons. So on isotopes, we can make a different video where we can discuss about the applications, where we can discuss about different examples, which is going to be radioactive. But before understanding the term radioactive, we need to understand the radioactivity part. So that we will be discussing in the future videos. So coming back to the same chlorine, over here we have 35 minus 17, that is going to be 18 neutrons, 37 minus 17, that is 20 neutrons. So we don't have a similar neutrons as of now. So coming, now we have 18. 18, that is argon. Ar is a symbol, it's a noble gas. So it will have 288 configuration. We had 287. So valence electrons are going to be 8. Valency is going to be 0 because it's a noble gas. Then if we go to mass number, now this mass number doesn't have any learning trick. It is 40. Now 18 plus 18 is 36 plus 4 is 40. So no logic behind it, but we can remember it. So number of neutrons, that is 40 minus 18, 22. Then we go to 19, which is potassium. In some of the countries, they pronounce it as potassium. So whatever feels comfortable to you. So potassium K, it's a metal. So 2, 8, 8 and 1. Now this is something tricky to understand at a basic level. Now most of the common question, okay, why? Why this one electron is going into the N, and why don't we have a configuration of 2, 8, 9? Why do we have a configuration 2, 8, 8, 1? So what is this special electron jumps to the fourth orbit? Why it is not staying in the third orbit? So these kind of questions are very common. So most of the time we say that you'll be understanding in higher classes, right? Right now you can just mug it up like that, but I'll try explaining this in a simpler term. So remember one thing, if we talk about electrons inside an atom, they differ by energy. So if they are in the K shell, their energy is going to be lower. L shell electrons energy will be higher, M will be higher, and so on. So we call these areas as shells or orbits, but we do have something inside it, some specific area where probability of finding an electron is more. We call them as subshells, or to be more precise, orbitals. So since electrons are occupying these k element shells based on energy from low to high, so this one electron, the 19th electron going into potassium over here, is getting some area in the fourth orbit having some low energy. So the next level, or you can say the next space that this 19th electron was supposed to occupy in the third orbit, is actually having higher energy. So if that electron is getting a position of low energy in the fourth orbit, then why not? That electron will jump over there, will fill that area having low energy, and again it will come back to the third orbit again. Now, this is a very simplified explanation that I'm telling you over here. Later on, when we'll discuss about subshells, quantum numbers, then we'll understand more about it, why this kind of behavior happens at the first place. So we'll stop over here and we'll come back to this same valence electrons. We have 1, valency is 1, mass number for potassium is 39. 39 minus 19 is 20 neutrons. So 39, 19 plus 19 is 38 plus 1, 39. So this follows in our learning trick, double plus 1, so we can follow that. Then if we go to the next, that is 20, calcium. So it's a metal. So its configuration will again 2882. So do remember these two electrons will, whatever area that we are talking about in the fourth orbit, the N shell, that area or that you can say subshell has the capacity to hold only two electrons. So if you see post calcium, that is 21. 21 is scandium. Sc is the symbol. So it will have a configuration of 2892. So again the 21st electron will come back to the third orbit and it will start filling over here, because we need to remember one thing: M shell has a capacity for holding 18 electrons, not 8. So we need to fill that third orbit. So from 21 to 30 atomic number, electrons are going to fill the third orbit. Now in that there can be 21 to 30, we can have some twists and turns. There can be a little bit of jumping from fourth orbit to third, or third to fourth, or you can say that happens again. Everything has a logic. Everything has a has an explanation when it comes to chemistry. But there are some levels. If we go with the proper sequence, we can understand chemistry better. Otherwise it becomes very tough to understand and to connect all the dots in chemistry. So we'll come back to calcium valence electron, since this is outermost. So two valence electron, valency is 2, mass number is 40. So double of calcium atomic number, so 20 neutrons. So we can write over here, if you can see, chlorine also has 20 neutrons. So we can write one example for isotones over here. So we can write potassium 1939, calcium 40, and we can write chlorine 1737. Yes. So they all have 20 neutrons. Now I wrote the electronic configuration of scandium like this. That's okay to write. But usually I never advise students to write in this format. It's always better to write in SPDF format. That we'll be starting very later on. So this is only for explaining you this part, that electrons will definitely come back to the third orbit and they will start filling the third orbit till the third shell capacity 18 for holding electrons, 18 number is completed. So 21 to 30, if we see the electronic configuration, 30 if we talk about, that is zinc, that is 28182, that is going to be the configuration. So if you ask me how do I remember 21 to 30, I never remember it like this. 28 something, it's very tricky because you have some two exceptional cases in 21 to 30, that is chromium 24 atomic number, and then you have copper 29. So there are some twists and turns. So it's better to remember the electronic configuration in SPDF subshell format instead of following the K-element shells. It's okay to follow the K-element shells format of electronic configuration till your 20 atomic number. Post that, I will never advise for in order to understand chemistry better, do not go with that, because you will always get confused that why this jumping is happening at the first place. So better to learn the correct format, correct thing at the first place instead of learning the wrong thing later on. So after this I'll be emphasizing on sequence of, if you can remember, 21 to 30, if 21 to 30 atomic numbers with the element name and symbols. This electronic configuration part we'll be figuring out later, not in this video. So 21 is scandium. So before moving to this, if you ask me how I have memorized all this, it's by heart. So it's very unusual for anybody to say that mnemonics are are simply headache for me because first you have to remember the mnemonics, and if you forget the mnemonics, then you'll forget the whole sequence. So It's better to learn by heart, but if you find so many videos online for periodic table, song, or anything, you can go ahead and learn that. Feel free. You can learn the mnemonics if it's comfortable. For me, it's different. No, the like by hearting is I try by hearting the periodic table in different format. So I try to remember in the form of blocks instead of periodic table song. The whole song is not required. And we don't need to remember the atomic numbers in that 1 to 118 like that. So there's a trick to memorize and understand periodic table in a better way. So we'll definitely look into that in the future videos. So 21 is scandium, and do remember 21 to 30 all are metals. You will see them in the third row of the periodic table, that is starting from group 3. So I'll write over here, this actually belong to group 3. So group 3, and group 3 I've told you before, it's a vertical column, and the horizontal row that we say is the period. So the horizontal row is actually the fourth period. So scandium, then we go to titanium. Ti is the symbol. Vanadium, chromium, manganese, iron, cobalt, nickel, copper, Cu is a symbol, zinc. So if we see most of the metals, that's my observation and many of the other teachers' observation also. If you see most of the elements in the periodic table, 90% of them are metals. And they actually end with the suffix ium. Now it doesn't apply to most of them. Like iron doesn't have it, cobalt doesn't have it, nickel doesn't have it, copper doesn't have it, zinc also is not there. Some of them. Now we have a manganese, it doesn't end with IUM. So I would say that, if it's very difficult to understand, which is a metal, which is not metal. So we can figure it out like this, that if any element ending with IUM, definitely it's a metal. So most of the metal names IUM suffix. So 21 to 30, try to remember. Then 1 to 20, all this data, all this information which I have shared, try to remember. If you can practice, if you can keep all these things in mind, then you can say the future steps are going to be more easier. Now, before finishing this video, let's have some questions. You can pause the video in between. So, calculate the number of total valence electrons or we can just write like this: calculate the number of valence electrons in N3 minus ion. Now the options over here: 10, 8, 5, 3. So Now, this is from the options itself. This kind of question can come in the mole concept also. We have a different, you can say, methods to answer that. But from the options, we can look at this from a certain angle that they're asking the number of electrons, valence electrons specifically. Now, and with this question, I want to explain one more thing. If you have an atom and if you have multiple shells, so whatever electrons will be present in the outermost shell, valence electrons, we call them, right? So we have something termed as core electrons. So core electrons are electrons present in an atom excluding valence electrons. That means you subtract valence electrons. Like if I say sodium is there, sodium atomic number is 11, 281 configuration. So valence electron we have just one. You keep that aside. So how many core electrons will be there in sodium? So it will be 10. That is the meaning of core. So valence, you remove that. Valence is only one shell. So the rest of the electrons, whether it's two shells, three shells, how many electrons, total of that is something, we call it as core electrons. Now, if we see this question, first we need to understand n atomic number is what? 7. So its configuration is 2 and 5. Now they're asking about n3 minus. What's the meaning of this? N3 minus means it has gained 3 electrons. So nitrogen is gaining 3 electron, changing into N3 minus. So nitrogen was having 7 electrons. Now it has 10 electrons. So it has gained in the outermost shell. So now it has a configuration of 2, 8. That is octet configuration, neon configuration. So how many valence electron this nitride ion has? N3 minus. So the answer is 8, if you can see. That's our answer. So I hope you have understood all these concepts pretty well. So I want to end this video over here. In the next video, we'll be discussing about chemical formulas, the language of chemistry from my understanding. So how do I look at the chemical formulas from my mind, how we can remember it easily, all those things we'll be discussing. Till that, keep learning chemistry, keep practicing it, and thank you for learning along with me. Thank you.